Hey everyone, this is Greg. I hope your day is going well, and thanks very much for all the good work in week 2. Welcome to week 3. And week 3 is when we actually start what's called inferential statistics. So in week 1, we did a little studying of summarizing data. Week 2 was the central limit theorem. The reason we spent time on the central limit theorem and the area under the normal curve was so we could transition into inferential statistics. Now, inferential statistics, it means to infer. We're going to take a sample of some things and we're going to try and find out what's true about a population. So let's take a look at a little example here. Now, from what we learned about the central limit theorem, the CLT, let's say I have a population and I don't know the mean of the population, but I know that it's normally distributed. Okay? So let's just say that it's the heights of 1-year-old babies or something in the population, and we don't know what it is. But here's what we do know, and this is what important because we're only talking about section 8.1 DQ1. Okay, DQ2 will change. It will be done a little differently. Now we know that the population standard deviation is 10. So we might have gotten that from a related population or some other data, but we don't actually know the mean of the population. Now, the central limit theorem tells us that all of those sample means are distributed. If we took the mean of the sample means, is what we did in the card trick, then the mean of those will equal the mean of the population. Okay? Well, now we don't know this. We don't know what this population mean is. But let's just say we take a sample and our sample size is 9 and our sample mean is 23. Okay? So sample size is 9, sample mean is 23. Now I just took some small numbers to make this easier to work with. And if you look on page, where is it? 256. Page 256 is the big one we will work with this week. Okay, this is the formula for what's called a confidence interval. And let's put the numbers in, then we'll spend a little bit of time talking about it. Okay, first of all, let's put the sample mean in the formula, 23. And then let's put, we're going to make this a 90% confidence level. So we're going to put 1.65 in there. And then we're going to multiply it by the standard deviation of the population. And we're going to divide it by the square root of 9. And let's write the formula again. And then let's write the same thing on the other side. 1.65 times 10 over the square root of 9. Now, the first thing to note, in this confidence interval, normally we'll use 3 types of confidence intervals. We will use a 90% confidence interval, a 95% confidence interval, or a 99% confidence interval. And these are the particular z values we will use for each. So we're going to build a 90% confidence interval for our estimate of the population mean. Okay, in here goes the sample size, 9. Here is the z value for a 90% confidence interval, and 10 is the population standard deviation. Now, when I work this out, this quantity becomes 23 minus 5.5 is less than 23 plus 5.5. And 23 minus 5.5 is 17.5. Whoop, you can barely see it. I'll move it up. Which is greater than, and this is 28.5. Okay, now, let's see if we can There we go. Sorry about that. All right, so what do we conclude here? We conclude that, I'm going to get that right. There we go. The mean of the population from which this sample came, we know that it is between 17.5 and 28.5, and we are 90% sure of that based on the central limit theorem. And that is how a confidence interval works. So, a couple things to note. You can choose different confidence levels, but these are the three that are most commonly used by statisticians. Okay? And the question might arise, well, if you know the standard deviation of the population, why would you not just know the population mean, and hence, why would you be going to all this trouble? Well, the fact is, let's say we know the standard deviation of the heights of females is 4 inches or something. Well, the standard deviation of the heights of males might be the same thing, although we don't know that, but maybe we can guess that. But there is a 1 or 2 inch difference in the mean height of males and females in the population, even though the standard deviation is probably the same. Now, in DQ2, we will take this assumption away, and we will take the sample values themselves, and we will find the standard deviation of the sample itself, and we will replace that with this standard deviation of the population. And then we will use a different table. We will use the t-table to find that confidence interval. But this is how we're going to start this week. So it's a matter of practicing it a few times and working with that formula. And I'll ask some more questions. I'll pull a little bit more out of you. But that is how the first DQ is going to go. Okay, so I appreciate everybody's hard work. Thank you for helping each other out in the DQs. That's really important. And if you go into the DQ and you do your very best and you try, you'll get full credit if it's on time. So if something's different than somebody else's, ask them the question why, and I will be there too, and we will resolve it together. Okay, well, thank you, and have a beautiful fall day.